Today, let's see the set data structure in little detail. So what is a set in Python? Set is an unordered, unindexed collection of items. So that's very important, unordered and unindexed collection of items in Python. So unordered simply means when we display the elements of a set, it will come out in random order. Unindexed means we cannot access the element using an index like we do in lists and tuples in Python. So that's an important difference. You cannot index it and it is unordered. So what else does a set offer to us? Set is basically a collection data type, just like the four popular ones, list, tuple, set, and dictionary. Set is a collection data type. What are the unique properties of the set? We will look at in detail using a few programs what the unique properties of a set are. Set is not ordered. You can add or remove values from a set, but you cannot change the values. This is a subtle difference. In tuple, you can't do anything. You cannot add, you cannot remove, you cannot change. Once you set the values, it stays forever. But set is little nuanced. You can add a value or you can remove a value from a set, but you cannot change it, right? And because you cannot change the values, you can call the values as immutable, and you cannot index the values. And the most important property of a set is you cannot have duplicates in a set, right? And this is one of the important properties of the set, just like the sets we have in mathematics. So Python also has a set which cannot have duplicates, which means that if you have a list of elements which has lot of duplicates and you keep adding and you convert the list into a set, automatically the duplicates are removed. uh, we can actually store different types of data in the set, but usually we store a single type of data, and you can nest the data structures in a set. So these are some of the qualities of a set. So let's look at the first way of creating the set. Just have these curly brackets and then put the values inside it. And here we go. So here I'm using a simple Jupyter notebook for writing the few lines of code and then showing you the examples. So here we have the set, which just has these curly brackets and then the values inside it. What's the other way of creating a set? By using the set function. So we have this set function and then we pass a list of values to it. As you can see, I have these two duplicate values and then two 45s are there, two 89s are there. So once you convert it into a set and then print it, you can see those duplicate values are gone. So you only have 145 and 189. So this is the other way of creating the set. So you have a list and then pass it to the set function, right? You pass it to the set function and then you have a set now. You can see the curly brackets here. So let's look at the Python documentation for the set. So you can see that here we have this set built-in function. So we are using this set built-in function here to create a set, right? This is the second way of creating the set. What's the other way of creating a set? It's very interesting actually. So first you create an empty set by using the round brackets, and keep on adding to the empty set. So this is a very interesting way of creating the set as well. So you create an empty set by using the round brackets and then keep on adding the values. If you add duplicate values anyway, the set will not take that. It will only keep one value of that. So you can see that I have created a set. So you can see the three different ways of creating the set. One is by using straight the curly brackets, then by passing a list of values to the set function, and then by using the add built-in function. So you might be wondering, what are the built-in functions for the set? Now, if you see this, because I'm using a Jupyter notebook, So adding a dot and then putting a tab here actually gives me all the built-in functions of the set. So one of the interesting thing about the set is it actually has a lot of these mathematical functions that you will find in the set entity in math. So you will see many of those mathematical functions also present here for the set. So you have add, clear, copy, difference, and difference update. So in another video, we would look at all the different built-in functions of the set and how they are different from each other and how they are useful too. So this is these are the different built-in functions of the set. If you are using a Jupyter notebook, just put a dot and then press tab. It will automatically show you the built-in functions for the set. Now, so once I have added everything, I have these values. Now, we saw there that I cannot index into a set, right? I cannot index into a set. You see, I'm trying to index and it's giving me an error. So it is giving me an error when I'm trying to index that. Since I cannot index into it, I cannot change the values in a set as well. So that is very clear that the values in a set are immutable. But you can add or remove from the set. You can add it by using the discard function. So you can see that I have a discard function here. So let me take a new set and then, I have a discard function that actually takes out the value 45 from this already present set. So which is actually equal to removing a number, a value from a set. You can add a new value as well as you can remove a new value, but you cannot mute. Okay, the values are not mutable, right? You cannot change the values in a given set. So these are the important properties of the set. So you can look at another video of mine for looking into the built-in functions of the set. The other important thing I want to share with you is set data structure uses hashing inside to store its elements, and that's one of the reasons why we cannot index into the set. So one of the properties of the set data structure is it uses hashing to store its elements. So we can also actually prove this, that it uses hashing. So you can see, let's say that I have a list of elements, right? And then I create a set by using these elements. As I was telling you, you can actually have a set which is a, heterogeneous which is of heterogeneous types inside. So this is an integer, this is a string, and this is a tuple. So I create a set using these values, and then I want to find what is the hash value of each of these elements. So I use a for loop and then use the hash function of each of these elements. So if you see that uh, the hash of these elements are printed here. The hash of the element 1 is 1 itself, hash of the element 2 is 2 itself, then the hash of the string hello is this, and then the hash of this tuple 4 5 is this. So as you can see, the set data structure uses hashing to store its elements. So these are some of the interesting things that are important. So what is the application of a set? In fact, uh, actually, sets are used for doing membership testing. That's the first thing that sets are used for. And sets are also used to remove the duplicate entries, right? Sets are used to do membership testing and to remove the duplicate entries. These are the two important applications that you can think of sets. Hope you found this video useful. Thanks for watching.